Marksman can hit the 10 spot on a target at 50 yards 89% of the time. If he makes 6 shots, find the probability that he lands at least 5 of them in the 10 spot. Okay, so when I read this problem, I think it's binomial probability. We actually had a video earlier that showed the same type of problem, same context. And in that case, they were asking for a different number of shots made, but still the same idea holds, that it's binomial probability. Again, quick recap why. There's more than one shot being made. 6 shots are being made, so it's either multiplication rule or binomial. Since it's a subset of the shots that are going to make it into the 10 spot, we're going to assume that it's binomial, and we can check the conditions like we did in the last video. I'm not going to do that again because we've already done it, but basically it's clear that this is a binomial probability. Okay, so now we're looking for the probability that at least 5 of them land in the 10 spot, right? At least 5 land in the 10 spot. So if that's the case, then what we're going to do is work out the following probability, right? If I say the probability of at least 5, I'm actually thinking for the probability that the number of successes is greater than or equal to 5. Remember, at least 5 means a minimum of 5. It could be higher, right? Now, there's only 6 shots being made, so I think that greater than or equal to 5 means the probability that x is equal to 6 plus the probability that x is equal to 5. I think those are the only 2 cases, right? Because greater than 5 or equal to 5 is either 6 or 5 in this instance, right? Okay, now if that's the case, then I want to fill in the formula twice and add the results together. Because it's either that, to be greater than or equal to 5, it's either that you have the value of 5 or you have the value 6. The word or means to add, so let's go ahead and work these 2 problems out and add them. So just recapping the probability formula here, it'll be n, which will be 6 in this case, choose x. X is going to be, for this first problem, 6. So 6 choose 6. Then the probability of success is going to be 0.89. That's the probability he lands the shot in the 10 spot. How many successes is he supposed to have? 6 in this example. That means the chance that he misses, which is 11%, none of the trials will be in that category. He'll have 0 misses out of 6 shots. Then you're going to add to that 6 choose 5. Now we're working the case where he gets 5 of them in. The chance he makes it is 89% again. That's the chance he makes a single shot. We want him to make 5 shots, so we're going to put a 5 on that. And then, of course, in this case, since he made 5, he misses 1, and the probability that he misses 1 is 0.11. Okay. The rest is really just calculator work. We can evaluate these without a calculator. If you have 6 items and you're going to choose 6 of them, they want to know how many ways that can be done. There's only one way to do that. You just take them all, right? So 6 choose 6 is just 1, so we don't need to worry about that. And you have 0.89 to the 6th power. This is just to the 0 power. In fact, you can see that because all of them are behaving the same here, right? All the shots go in, right? They all land in the 10 spot. In that case, you could have just used straight multiplication rule, because this term is just 1, this term is just 1. So in the end, this whole thing reduces to 0.89 to the 6th power, right? Then you'll add to that this. Well, 6 choose 5. Whenever you have something like that, 6 choose 5. So this number and this number are just 1 apart like that. The answer is just going to be this number. So it'll be 6 ways. You can work that out in your calculator, but if not, you can take my word for it that it'll be 6. And then it's times 0.89 to the 5th power times 0.11. Of course, to the 1 power is just that. And then if we work that out in our calculator, we get the following result. We'll have 0.89 to the 6th plus 6 times 0.89 to the 5th times 0.11. After working all of that out, we end up with the result of 0.865529 ... And this will turn out to be, as a percentage, 86.6%. And that's it.